Abhirami from Whaltech Multitech Engineering College, and my project title is Decentralized Access Control with Anonymous Authentication of Data Stored in Clouds. An abstract. Here propose a new decentralized access control scheme for secure data storage in clouds that supports anonymous authentication. In the proposed scheme, the cloud verifies the authenticity of the server without knowing the user's identity before storing data. The scheme also has the added feature of access control in which only valid users are able to decrypt the stored information. The scheme prevents replay attacks and supports creation, modification, and reading data stored in the clouds. The communication, computation, and storage overheads are comparable to centralized approaches. Existing system. On access control in cloud are centralized in nature, except and all other schemes use attribute-based encryption, that is ABE. The scheme uses a symmetric key approach and does not support authentication. The scheme do not support authentication as well. It provides privacy-preserving authenticated access control in cloud. However, it takes a centralized approach where a single key distribution center, that is KDC, distributes secret keys and attributes to all users. Unfortunately, a single KDC is not only a single point of failure but difficult to maintain because of the large number of users that are supported in a cloud environment. In this project, that our previous work with added features which enables to authenticate the validity of the message without revealing the identity of the user who has stored information in the cloud. Our scheme also allows writing multiple times, which was not permitted in our earlier work. The disadvantages: proposed a distributed access control mechanism in clouds. However, the scheme did not provide user authentication. The other drawback was that a user can create and store a file and other users can only read the file. Write access was not permitted to users other than the creator. Proposed system: distributed access control of data stored in cloud so that only authorized users with valid attributes can access them. Authentication of users who stored and modified the data on the cloud. The identity of the user is protected from the cloud during authentication. The architecture is decentralized, meaning that there can be several KDCs for key management. The access control and authentication are both collision resistant, meaning that no two users can collude and access data or authenticate themselves if they are individually not authorized. Revoked users cannot access data after they have been revoked. Advantages: users can have either read or write or both access to a file stored in the cloud. All communication between users, clouds are secured by Secure Shell Protocol, that is SSH. Next, hardware configuration. And the hardware configuration here using RAM is 256 MB, hard disk 20 GB, mouse is standard mouse, keyboard standard keyboard, and monitor SVGA LCD. Software configurations: operating system is Windows, application server Tomcat 6x7, Java version is JDK 1.7 by 1.8, front-end HTML, Java, JSP, scripts, JavaScript, database MySQL 5.5, database connectivity, JDBC. Modules: access control, authentication, attribute-based signature, cloud storage. Access control. Authorized users have access to valid servers. A huge amount of information is being stored in the cloud, and as much of this is sensitive information. There are broadly three types of access control: user-based access control, role-based access control, attribute-based access control. Authentication. Authentication scheme is correct, collusion secure, resistant to replay attacks, and protects privacy of the user. First, note that only valid users register with the trustee receive attributes and keys from the KDC. A user's token is y is equal to u k base k naught row, where row is the signature on u, k base with tsig belonging to the trustee. An invalid user with a different user ID cannot create the same signature because it does not know tsig. Attribute-based signature. To ensure anonymous user authentication, attribute-based signatures. It was also a centralized approach. A recent scheme by the same takes a decentralized approach and provides authentication without disclosing the identity of the users. Next one is cloud storage. Write proceeds in the same way as file creation. By designating the verification process to the cloud, it relieves the individual's user from time-consuming verifications. When a reader wants to read some data stored in cloud, it tries to decrypt it using the secret keys it receives from the KDCs. Next, architecture diagram. Here user 1, user 2 and user n is entered into the access control. In access control, here we are having access control list. In access control list, there are three types: user based, role based and attribute based. Then enter into the authentication. Next is attribute based signature. The signature is derived from the KDCs and the encryption process is done here. After matching the attribute keys, the decryption process is done. After that, the original message is stored in cloud. Next one is server login. Here a server is login by giving the username and password. Next, after server login, uploading a file by choosing the file from the encrypt file key. Here encrypt file key is file key and file name is given by the users, which can be used to upload the file. User view and select file to send data. The user want which file to send, which file want to download to send request to the user view. Download file using private and public key. Here private and public key is used to download the files. After downloading the files, this is then server side view. Here we can see the download status. The file is downloaded. Thank you.